Hello everyone and welcome to a new lecture. In this video we're going to talk about a very tiny concept, and that is the concept of higher order derivatives. Okay, so what is this? What is higher order derivatives? Well, suppose I have f of x to equal to, so let's do it in red actually. Suppose I have f of x to equal to 4x to the 3. Okay, if I ask you to find me f prime of x, okay, basically what you will do is you will find the first derivative of the function. Okay, and here we have a constant multiplied by a variable raised to a power. We're just going to use the power rule. We're going to bring the power down and then we're going to subtract 1 from the power. Okay, so basically it will be 4 times 3 multiplied by x raised to a power of 3 minus 1, which equals to 12 raised to a power of, or multiplied by x raised to a power of 2. So f prime of x actually equals to 12 multiplied by x raised to a power of 2. Okay? But what if I put this? What if I ask you to find me f double prime of x? Okay? What is this? Here we have 1 prime. Here we have a double prime. Well, it's very, very easy. Okay? I'm asking you to find me the derivative of the first derivative. Okay? So if the first derivative equals to 12x to the 2, basically find me the derivative of that. So it equals to, so it will be 12 times 2 multiplied by x raised to a power of 2 minus 1, which equals to 24 multiplied by x raised to a power of 1. So this is basically what is called a higher order derivative. You are not finding the first derivative, but you are finding the second derivative, the third derivative, the fourth derivative, and so forth. The higher order derivatives. Okay, because so far we have only found the first derivative, but it's possible to find the second derivative. To find the second derivative is you will take the first derivative and then you will take the derivative of that. To find the third derivative, you will take the first derivative and then you will take the second derivative and then you will take a derivative of that. So f prime of x, that is the first derivative. F double prime of x, that is the second derivative. F 3 prime of x, so this is the third derivative. We can have the fourth derivative. We can have the fifth derivative of x and so forth. So for the first derivative, you'll just take the first derivative of the function. So it is f prime of x. For the second derivative, you'll take the derivative of the first derivative. So it will be f prime of x. Okay, and so forth. So the third derivative will be f prime of x. Okay, so suppose I have x to the 5. If I want to find the first derivative, it will be 5x to the 4. If I want to find the second derivative, it will be 5 times 4 times x to the 3. If I want to find the third derivative, it will be 5 times 4 times 3 times x to the 2. The fourth derivative, it will be 5 times 4 times 3 times 2 times x to the 1, and so forth. So that is basically higher order derivatives. And we're going to use not the first derivative, but the second derivative when we talk about graphing functions. Okay, that's why I'm talking about this right here. But be careful. So here we have f prime of x, f double prime of x, and so forth. So if I ask you to find me f prime of x, I'll just write f, a bracket, and then a 1, and then a bracket of x. Okay, if I change this 1 to 2, that means find me the second derivative. If I change it to the 3, find me the third derivative. But you have to have these brackets around this, or else if you write f to the 3 of x, that is basically raising the power of your function to the 3. Okay, so this is the notation. If you want to find the first, the second, the third, or the higher order derivatives, that's basically how you write them, or this is basically how you write them. Okay, so let me give you actually an example. So let's delete all this. Suppose I have, so example 1, suppose I have f of x to equal to 5x to the 4 minus 7x to the 2 minus 1. Okay, and I'm asking you to find me the third derivative. Okay, so find the third derivative of this function. Okay, so the first derivative basically, so f prime of x actually equals to 20x to the 3 minus 14x, and then this, the derivative of that is just 0. Okay, f double prime of x actually equals to 60x to the 2 minus 14. The third derivative of this function actually equals to 120x x. Okay? You can notice, if I asked you to find me the fourth derivative, you'd end up with a constant, okay? And if I asked you to find me the fifth derivative, it would be 0. Okay, so that is something to keep in mind. If you have a polynomial like that, and if you look at the highest power, okay, if I ask you to find me the derivative, okay, so suppose the power is 5. If I ask you to find me the fifth derivative, you'll end up with a constant. If I ask you to find me the sixth derivative, you'll end up with a 0. You can actually check it out. So suppose I have f of x to equal to x to the 4, and I'm asking you to find me the fifth derivative. So find me the fifth derivative of this function. Okay, so according to this, if I find the fifth derivative, it will be 0. So let's see if it's like that. So f prime of x actually equals to 4 times x to the 3. The second derivative equals to 4 times 3x to the 2. The third derivative equals to 4 times 3 times 2 times x to the 1. The fourth derivative equals to 4 times 3 times 2 times 1 x to the 0. Okay? X to the 0 is just 1. So as you can see, the fourth derivative is just a constant. It's 4 times 3 times 2 times 1. The fifth derivative is a 0, because its derivative of the constant is 0. So if you have x to the 100, and I'm asking you to find me the 101 derivative of this function, well, it will be 0. What if I ask you to find me the 100th derivative of the function? Well, find the derivative of the first, the second, the third, and the fourth, okay? And then see if you can find a pattern. If I have a variable like this raised to a power, okay, so suppose the power is n, well, if I ask you to find me the nth derivative of the function, well, basically it will be this. What is this? Well, if the power is 4, then the fourth derivative is 4 times 3 times 2 times 1. It is just factorial of 4. Okay? If the power is 100, and I ask you to find me the 100th term, then the derivative would be 100 factorial. As simple as that. Okay? So, in a nutshell, that is basically what higher order derivatives are. Attached to this lecture, there's a document where you can download it and practice this concept. And as I mentioned, we're going to take advantage of higher order derivatives, specifically of the second derivative, when we talk about graphing functions, specifically when we talk about concavity. Okay? So, with this, we come to the end of this lecture.